Well, hello friends. Today we are going to make a new bitmap format because I got a feature request to have palette indexed graphics bitmaps. And I think that should be relatively straightforward to do. So let's just jump right into it. And I'll make this a bit bigger here. So in GraphicsBitmap, I'm just going to go and add right here, call it indexed 8. And what this is going to be is it's just going to be 1 byte per pixel, and it's an index into a 256 entry palette that will keep, I guess, somewhere in the bitmap. I guess we can put it on side. We'll call it something like byte m palette. And of course it will be null usually. And it can't be a byte, it has to be RGBA32 actually. Yeah, because it's going to be 1 RGBA32 per entry. Okay. So, that's the basic part of it. Now, of course, we need to actually implement this. So let's start out by writing a little test program that will make use of it, and then we can build it around that. So let's see, let's make a new program called Indie. Okay, and crash clear, and libGUI. So let's make a very simple libGUI app for this. So we need a widget and a window. And I guess we can use a glabel. Or, you know, let's make a custom widget actually. So G application. So this is how every G application program starts out. It's if you ever did Qt programming, then you definitely would feel familiar. Talking while doing this is difficult. Okay. So let's see, auto window, new G window, new G widget, window set main widget. So every window has a main widget. And that's just a widget that's like the root layer of that window. And usually I like to do a set fill with background color true, so that we get a background color for the window. And background color should be, I guess, we'll go with dark gray, and then we're going to paint something over this. So we can actually not use a custom widget, but we'll just use a label instead, because label has this nice feature that it allows you to set an icon on it, which is a bitmap that will be displayed instead of text. If set. So let's make one of those. And we'll make him a child of that widget. And let's give the widget a layout so that the label is automatically grown to the size of the window. Wait, hold on, what am I doing? Make gbox layout. Orientation vertical. We have to include gbox layout. Okay. And now for the big new thing. So let's say auto bitmap is GraphicsBitmap create GraphicsBitmap format indexed 8. And let's make it say 100 by 100. Okay. And then let's see, bitmap. Then we should make the palette, I guess. So let's see, set index color. Should we call it that? Set palette color. Palette color is pretty good. Set index color is pretty good too. I like palette color. Okay, set palette color. We will add some cool colors here. So let's say that this one is, maybe we could do it like this actually. We could have it take a color, make it a bit more readable. So we'll have red, and why not green, and yellow. That old EGA palette. Okay, and then we gotta add that function. Set palette color. I guess byte and color. And we'll also have a getter for this. So we'll say byte, index, columns, return, and palette index. And I guess, yeah, this thing could actually just be an inline setter as well. So we'll just do it this way. mPalette index is color.value. From RGBA. Right. I think that's cool. Okay. And how do we paint into this thing now? So we'll do something like memset, bitmap, scanline 0. Or let's do it this way, actually, for bitmap height. Bit is bitmap scanline y. And we'll do memcopy. It's, we can call it pixels. And then we'll initialize with, let's initialize with red. I think that would be cool. And that will just be an interesting start. Okay, and then we'll say label, set icon, pass the bitmap, and then we'll just show this window and return @exec. So this will transfer control to the GML loop. Why don't you like me? Is it because I need to do a star? Yeah. Okay. So we have our indie program. Of course, this is gonna need a lot of rebuilds. So let's make a command right away. Actually, make the rm.userland indie and makes userland indie and sync and run and make, because we're gonna be in libgui. Screw around. Okay. So now that we created this bitmap here and we assign it to the label, we're going to end up in glabel paint event with a unusual, let's see if it even runs now, with an unusual bitmap. So yeah, this is just because we're trying to set colors on the palette. So we got to make a palette allocation first of all. So this is the constructor that we're in. So let's say that if format is format index state is I guess new RGBA 32 256. And in the destructor, we gotta make sure that we delete and palette. Okay, now this is all black because we don't know how to interpret the zeros, right? We're still falling in the old code path where 0 means black, but in this case, actually they're not all zeros. I guess they're all ones, so, but it's very close to black. But we are supposed to figure out that that means red. So in glabel paint event, we call, if there is an icon, then we call painter either draw scale bitmap or painter blit. And let's start with, I guess, painter blit, because this is a special mode if you're allowing stretching. So we'll start with implementing blit, and then we can go through the others. So this is painter blit. It's the main driver for RGBA copy, basically. Let's see what we can do here. So we have to special case the new format of the source bitmap, because we're not gonna support using a painter and targeting an index 8 bitmap, but we're gonna allow using it as a source, obviously, for blitting. So this thing here that we're doing is not gonna work. So one thing we could do is we could start making a generic version of this so that when we add other formats to GraphicsBitmap in the future, then we'll have a generic fallback implementation that you can then like optimize for this specific format. So because this thing here is like already specific to RGBA 32 bitmaps, but a generic version would be something more like this part is still the same. And we'll do something like, I guess, DST. Oh wait, hold on. What is set up here? So are we getting the scan line from the source? But this isn't always that, right? So, actually, I don't think I want to write a generic version of this. I would rather do something like say that this part here is all the same, but then this is specific to the 32-bit versions. So if source.format or source.format into this, return, and then we'll have it source format is GraphicsBitmap. No, not invalid. We'll do return at the end of that, and then we'll say assert not reached here. And DST plus equals DST. So now DST is an RGBA 32 array where we just want to copy over the pixel values one by one, and we want to get them from source bitmap, which is now in a slightly different format. And let's see, so this is the scan line that we want to be getting. But the scan line thing is not going to work exactly the same. So it's going to be something like this. We'll call it like pixels. I guess, yeah, scanline is kind of a dumb name for this function because it's not always a scanline. I see now why a lot of people end up calling it like bits or pixels instead of scanline. Whatever, it doesn't matter. We'll just add a new function to GraphicsBitmap called bits that returns a byte actually, I guess that this can just be the same as... It can just be the same as this guy. Yeah, so you can really just do like that, and it doesn't matter. Const height. Notice that I'm only adding a const version because I never want to write into the thing here. Maybe I'll want that later, but right now this is enough. Okay, so now we have source, and then source skip is, I guess, the pitch. Yeah, source skip, and then do something like this. Clip track dot width plus I. DST I is source dot palette color source I dot value. Feeling brave. Honeybee, yes, very nice. Okay, now we have this guy here, and I suspect that that will work quite well. So what other functionality do we want to test? Well, let's just check that that all the colors would come through. So we'll do something like text, or actually we can do like that. And we'll get a different color for every line. We didn't get that. Why do we not get that? What am I doing that's stupid? Why is my brain stopping? Okay, color trend 4. I gotta debug my brain. Gotta printf debug my brain. I guess this should be a byte, actually. I'll say well, we're setting all the different colors. So something here didn't go well. And what is that exactly? Well, we'll find out. Let's see, pixels. I just verify that the scan lines are all, that they're not overlapping for some reason. No, they look like they are spaced out. Okay, then I guess we gotta look at that painter code that we wrote. Source I. Oh shit! Wait, this is suspicious. See, we're doing this inside the loop here. That's not gonna work. We gotta do this outside the loop. Otherwise, we're just starting from the first line every time. How silly of me. Okay, there we go. Pretty cool. Pretty cool. Okay. That's good. So I guess we should look at some other stuff well, the first thing we can do is just to put assertions everywhere that that we have a supported supported mode. But I was thinking we should implement draw scale bitmap as well, because that's just always useful. So let's make that thing a scale bitmap by calling labels that should stretch icon true, which will cause us to call painter draw scale bitmap instead. And then the source pixel is fetched here. So I guess we will do something like this. This is very unoptimized code, as you can see. And I'm not going to sit here and try to optimize it now. I'm just going to make it work. So let's see, switch source dot format. Oops. I mean, it's almost like we could have a freaking get pixel function on the bitmap, now that I think about it. So let's just have that instead, get pixel. And then we'll just take scale y, or scale x, scale y. Yeah, because that's what that code was doing anyway. So let's see, and let's write out a, I mean, it's obvious that it's in line, so color, int x, int y, const, and let's say switch m format. Return scan y x. Guess. I mean, yeah, so for RGB we can actually do this, and then it will come out in full alpha. I mean, with 100% opacity. So that's slightly nicer. And then for indexed, M palette, bits y, x, and we need a color from RGB. I mean, it could have alpha, so fault certain not reached. Okay. This is a really naive nearest neighbor scaling algorithm here, as you can see, just picking pixel by pixel based on the scale of coordinates in the source bitmap. Okay, let's stretch this. Look at that. How very, very nice. I think this might be useful for the person who requested the feature. But maybe there's something useful that I'm not thinking of right now, but I'm going to commit this code, and actually let's do a little bit of a smoke test here just to make sure that I'm not screwing something up horrendously. Can do some stuff here like assert format is not. Because I gotta handle this in those situations, so that'll be just to fix me. Although this one, I think we're not going to support shared buffer, anything other than the 32-bit shared buffer. For the mapped file, that might be different, like that might be useful. This thing, creating it around an existing one, definitely should have to be 32. Yeah, okay, so let's just make sure that we didn't break anything. It's looking fine. Let's put some opacity change here and a little bit. Everything looks normal. And then we'll run the test program. Oops. Oh, wait, where did you go? Here. Yep. Very, very nice. Okay, let's commit. I mean, first let's do a patch review. Okay. So in GraphicsBitmap, we are now checking in the constructors. If it's an index 8 in the one constructor where we allow it, then we instantiate or create a palette. And then in the other constructors, we just assert that no one is constructing with this format. In the destructor of GraphicsBitmap, we delete the palette. I mean, if it's nominal, obviously. Then here in GraphicsBitmap, we add a new format called index8. We add a new byte array getter here, for getting the bytes corresponding to one row of pixels. And these guys here are for the palette stuff. I was thinking, like, should we have assertions here, but it's just gonna crash anyway, and you'll figure out why it's crashing. I would add assertions, but like I don't like doing that in this extremely hot code. And these things are gonna get called for every pixel, at least this one, maybe not this one. I mean, we could do it for set palette color actually. Well, no, because somebody's gonna do that in the loop too. Okay, maybe I should reconsider, but not now. So here's getPixel, which is just a factored out helper for retrieving one pixel from a bitmap, and just doing exactly what you would expect. This one goes indirectly through the palette to get the actual RGBA values. Right. Here's the mPalette pointer for GraphicsBitmap. So GraphicsBitmap grows by one pointer, which is negligible, it doesn't matter. Okay, so now in Painter Blit, when the source format is RGB32 or RGBA32, then we do the old thing. And if it's index 8, then we do the new thing, which is that we convert it using the palette color helper. Cool. And then down here in Draw Scale Bitmap, there's one thing I don't like there, which is that I unnecessarily changed this from auto. Ah, that's nicer. Okay, cool. I'm going to commit this without the test program, because that was just a throwaway. But we'll say Painter, no, GraphicsBitmap actually. Add a new indexed 8 format that uses a 256 entry palette. These bitmaps should only be used as a source bitmap, never as a painter target. It will not be possible. No, we won't support painting into them. You can, however, manipulate the pixel here. Cool. All right, let's push that and look at it one more time. Isn't that cool? We have a palette-based GraphicsBitmap format. It'll be interesting to see what you might create with that. Okay, I think this is going to be it for today's video. So if you made it here, then I thank you for watching, and I hope you saw something interesting, and I will see you next time.